Welcome to the Year 12 PPE question 13 on proof. Now, I'm going to do this in two ways, part A. First of all, I'm going to start with the left-hand side and work across and show that it is a true inequality. So we're going to start by just writing down here question A, and then I'm going to rewrite it first of all like this. So I'm just writing the left hand side as a statement, okay? 9a over b plus b over a, then I'm going to take away 6 from it, okay? And I'm now going to work on what that equals. I can't use the statement because as it is, because I'm assuming that it's true if I do that, and I've got to prove it's true. So I'm going to say 9a over b plus b over a minus 6 is the same as this, okay? So all I'm doing here is I'm finding a common denominator of ab, okay? And I'm then adding b squared over ab, and then I'm adding or subtracting rather 6ab over AB. Okay, now on my next line I'm going to write that all of that is equal to 9a squared, okay, and I'm going to change the order of the second and third terms because I know that this is leading to a perfect square, okay, and that's what they were wanting you to spot quite early on in this problem, I think. So that is that over AB, okay? And now I can write that as the perfect square and write it as 3a minus b all squared, okay, over AB, okay? Now, at this point, you can introduce the inequality sign and say that that is always greater than or equal to 0. And you can say that for two reasons. I'm cheating a bit here to save time, but they're here in the straight out the mark scheme. Okay? And you need to write those down or something to that effect. So when you square any real number, it's always greater than or equal to 0. Okay, so it doesn't matter what a and b are, that can be a negative number in that bracket. If you square it, it's going to be positive. Okay, greater than 0 or equal to 0. Okay, the only way it would be less than 0 is if a and b weren't real numbers, and we have to assume that they are in this problem. And then underneath we have a positive number. Okay, so AB is always positive because it tells us that both A and B are positive numbers. So because the denominator is always positive and the numerator is always positive, the whole thing is greater than 0. So, and because the denominator is positive, we can just remove it and conclude that the numerator must be greater than 0 on its own. Okay, so therefore we can say that 3a minus b all squared is greater than 0 or equal to 0. Okay, and because of that we can say that 9a squared minus 6ab plus b squared is greater than or equal to 0, and then we can start working backwards, if you like, from where we came from. Okay, but we're now proving the result is equal to 6 on the right, or greater than or equal to 6. So the next step is to write that 9a squared plus b squared, okay, is greater than or equal to 6ab, okay, because I'm just moving the 6ab, which is all positive, remember, onto the other side. And then if I divide by ab, I can say that 9a over b plus b over a is greater than or equal to 6, which is the result we had to prove. Okay, now I'm going to show you a different method which you can do on the knowledge that comes from the year 2 book, which is about proof by contradiction. Let me see if I can make that a bit smaller and just keep it over to the side, so I've got a bit of space to work on the other side. So if we come down here now and partition this off, okay, if I go to, I'll do this in a different color. So this is an alternative method of doing the same problem. So I'm just going to put here or, okay, by contradiction. I'm going to assume now, that there exists values of a and b, okay. Let's say there exists a and b greater than 0, such that the opposite of this is true. In other words, that colon there means such that, this is all shorthand to save a bit of time, that 9a over b plus b over a. Now the opposite of being greater than or equal to 6 is it being less than 6. Okay, so I'm going to assume that's true. Now, because I'm assuming this whole statement is now true, I can just manipulate it. And if that was true, it would imply that 9a squared plus b squared would be less than 6ab. Okay, I've just multiplied everything by ab. Then I'm going to say, okay, well, if that's true, it also implies that 9a squared minus 6ab plus b squared is less than 0, which would imply that the perfect square 3a minus b all squared is less than 0. Okay, but this cannot be true. Okay, cannot be true. Okay, and the reason it cannot be true is since, well, we've got it here again to save time. Because of this, let me make it slightly smaller. So it's pretty much the same reasons as we used before, because when you square any real number, it is always greater than or equal to 0. And dividing by AB does not change the inequality as A greater than 0 and B greater than 0. Okay, so those are the two facts I'm using there. Okay, because what I did here is I multiplied by AB. So to get back to the result that I need, I'm going to divide by AB, which I can perfectly well do because it's positive. Okay, so that cannot be true. So therefore my conclusion is that 9a over b, in other words, I'm taking this thing here and dividing by AB. So 9a, okay, over b plus b over a is greater than or equal to 6, because it's not the same as my original statement. It's the contradiction of it. Okay, so I proved that by contradiction. Okay, proved by contradiction. Okay, so quite a lot to write down, but we've done it two different ways. You would only need to use one of those methods. Okay, now finally we've got part B of the question to do, so I'll just do that up here. and this is really quite easy, and it is only 1 mark, so you don't want to spend too long on it. You just got to pick a pair of values. Now, they're saying that here it's about all positive values of A and B. Now they're saying, proved by counterexample, it's not true for all values of A and B. So the implication is that you've got to have one of them being negative. Don't make it complicated. Just choose something like 1 and -1. Okay? And then plug them in and see what happens. We would get, wouldn't we, 9 times 1 divided by -1 plus -1 over 1, and that would equal -9 minus 1, so it will be -10, and -10 is less than 6. Okay, it's not greater than or equal to 6, so therefore statement result is not true for all values of A and B. Okay, it is true for positive values of A and B, but it's not true for all values of A and B. Okay, and that summarizes and proves that part. Okay, so that's part B. Part A, you can either do this version or this one here. Okay, take care.